your Kalpana here. In this video, we are going to solve two problems, or we are going to evaluate two integrals, right? So first one, evaluate integral sin x by 1 plus sin x into dx. So now we are going to rationalize the denominator. So for that purpose, we are going to multiply and divide with 1 minus sin x into dx. So this equals to integral sin x into 1 minus sin x by 1 plus sin x into 1 minus sin x. Since in the denominator we are having 1 plus sin x into 1 minus sin x, which is of the form a plus b into a minus b. So this equals to a square minus b square. So here in the next step you can change it. So you could write it as sin x into 1 is sin x minus sin x into sin x is sin x or sin square x, sin x whole square or sin square x by a plus b into a minus b is equals to a square minus b square. So you could write it as 1 square minus sin square x. 1 square is again 1. So you'll get 1 minus sin square x in the denominator. So this equals to integral sin x minus sin square x by, since we know that sin square x plus cos square x equals to 1. So from this you'll get cos square x equals to 1 minus sin square x. Since in the denominator you're having 1 minus sin square x, so you can replace it with cos square x. Okay. So this equals to integral sin x by cos square x into dx minus integral sin square x by cos square x into dx. So you would write it as sin x by cos x into 1 by cos x minus, dx minus sin x by cos x whole square, or you can leave it like this. Okay. Since we know that sin x by cos x is tan x and reciprocal of cos x is secant x. Since sin x by cos x is tan x, sin x by cos x is tan x. If you square on both sides, you'll get sin x by cos x whole square equals to tan square x. Okay. Or you can write as it is. It could be better. Okay. Since sin x by cos x equals to tan x, if you square on both sides, you'll get sin square x by cos square x equals to tan square x, and reciprocal of cos x equals to secant x. Okay. So this equals to integral. Now replace sin x by cos x with tan x into 1 by cos x with secant x into dx minus integral sin square x by cos square x with tan square x into dx. Since we know that 1 plus tan square x equals to secant square x, then from this we'll get tan square x equals to secant square x minus 1. So this becomes integral tan x into secant x dx minus integral of, now replace tan square x with secant square x minus 1 into dx. So this is equals to integral tan x into secant x into dx minus integral secant square x dx minus into minus plus integral dx. Okay, since integral tan x into secant x dx equals to secant x plus c, and integral secant square x dx equals to tan x plus c, and integral dx equals to capital X plus, not capital X, sorry, x plus c. Okay, so now we can apply these formulas. So we'll get integral tan x secant x dx equals to secant x minus integral secant square x is tan x plus integral dx is x plus integral constant c. So therefore integral sin x by 1 plus sin x into dx is equals to secant x minus tan x plus x plus c. Now coming to the second problem, evaluate integral secant x by secant x plus tan x to dx. So here also we are going to rationalize the denominator by multiplying and dividing with secant x minus tan x. Okay, so this is equals to secant x into secant x minus tan x by secant x plus tan x into secant x minus tan x to dx. So this is equals to integral secant x into secant x is secant square x minus secant x into tan x by secant square x minus tan square x to dx. Okay, since this is of the form a plus b into a minus b, a plus b into a minus b is a square minus b square, so we could write it as secant square x minus tan square x. Okay, so this equals to, since we know that secant square x minus tan square x equals to 1, so this becomes secant square x minus secant x into tan x by 1 into dx. So this is equals to integral secant square x minus secant x into tan x into dx. So you could write it as integral secant square x dx minus integral secant x tan x into dx. Okay. Since we know that integral secant square x dx equals to tan x plus c and integral secant x tan x dx equals to secant x plus c. Okay, so this becomes, since we have secant square x dx, integral secant square x dx is tan x minus integral secant x into tan x is secant x plus integral constant c. Therefore, integral secant x by secant x plus tan x to dx equals to tan x minus secant x plus integral constant c. This completes the problem. So we have seen 2 problems in this video. Hope you will understand. We'll see you in the next video. Until then, bye bye.